Welcome. Thank you for joining us on today's TREDIS webinar, focusing on bridge and pavement preservation programs from an economic perspective. My name is Kirsten Hughes. I am the Director of Sales and Marketing for TREDIS Software and your moderator for today. This event is part of a continuing educational series of webinars that we offer. Some of our webinars focus on broader issues of concern to federal, state, and local transportation planning organizations and their consultants. Other webinars focus on the technical features and capabilities of TREDIS. The content of today's webinar is technical in nature and is appropriate for advanced TREDIS users. Since many of you are currently using TREDIS or have attended previous introductory webinars we have hosted, we plan to jump right into the technical content. Presenting today, we have Senior Economic Analyst Adam Winston. Adam will demonstrate TREDIS use for pavement preservation programs. Then, Planning and Policy Analyst Kyle Schreckenthaler will demonstrate TREDIS use for bridge preservation or replacement programs. Adam and Kyle will be using hypothetical preservation case studies to address the following questions. How does TREDIS use outputs from your asset management systems to determine why preservation is important? Depending on your requirements and assumptions, are additional data inputs required in order to run the model? How can you use custom modes and other features in TREDIS to model preservation projects? And most importantly, how do you communicate the value of investing in preservation from an economic perspective? We'll end our session with a question and answer period where you'll have a chance to ask your questions. Please feel free to enter your questions into the webinar chat box as we go through the demonstration. There is no need to wait until the end of the demonstration to submit your questions. Now I'll hand over the presentation to Adam. Adam?
Okay, thanks, Kirsten. I'll be going over an example here to help demonstrate how TREDIS can be used to evaluate a particular aspect of your asset management program. In particular, I'll be going over how we can evaluate a pavement preservation program and use TREDIS in a way that we can evaluate the efficient use of resources within this program, how much contribution is made to the regional economy in terms of jobs, wages, and other economic measures, as well as specifically what industries appear to be most responsive to these improvements in pavement conditions. So in the example that we've developed to highlight the features and capabilities in analyzing this program, I've developed the following scenario. So we're assuming that this study region that we're evaluating is Suffolk County, which is a county here in Massachusetts. And within this region, we're estimating that roughly there's 100 million vehicle miles traveled that's occurring in the year 2016. Now that's expected to increase up to 200 million by the year 2045. Right now, we're assuming that 90% of these vehicle miles are associated with passenger cars, and then the remaining 10% is associated with freight trucks. Pavement conditions in the current year are roughly about 50% good, and the other 50% is in poor conditions. If there's not any additional investment by the year 2045, some pavement condition modeling analysis has estimated that the amount of pavement in poor condition is unfortunately expected to rise up to roughly about 70%. However, using this, say, modeling process, if there's an investment of $750,000 annually out to the year 2045, that is expected to improve pavement conditions up to roughly about 80% in good status and 20% poor status. So in these this is just a hypothetical example, but typically this information can be gathered from asset management systems such as HERS, ST, or other asset management programs. So to answer the question, how are good and poor pavement conditions defined? this slide presents two different rating categories, and the links between the two has been made by the Federal Highway Administration to understand the relative magnitude and how they compare to one another. The first one is the present serviceability rating, or PSR. This is more of a subjective rating system based on a scale from 1 to 5. And prior to 1993, all pavement conditions were evaluated using this PSR method. Over here to the right, the IRI stands for International Roughness Index. And this is calculated by estimating the cumulative deviation from a smooth pavement surface measured in inches per mile, or centimeters per kilometer. And that's determined usually by like a laser measuring tool along any interstate or other road. And International Roughness Index is now the reporting standard for all states. In this example, we're defining good pavement as having an IRI of between 60 and 94 inches of deviation per mile, and poor of an IRI of 170 inches deviation per mile or higher. One additional piece of information necessary for the analysis is the additional costs imposed by deteriorated pavement conditions on vehicles. Here on this slide there are several different estimates of vehicle operating costs associated with poor pavement condition from a variety of published studies and technical reports as shown in this slide. Just to simplify this example, we used a 20% increase estimate in vehicle operating costs to account for poor pavement conditions. Poor pavement often causes greater wear on vehicles, including tires, which require additional maintenance and repair, but can also accelerate depreciation costs associated with use in poor pavement conditions. This slide shows the non-gasoline and non-diesel operating costs for autos and trucks. And each of these modes and pavement conditions will be given a customized mode purpose category, which I'll show in the live demonstration. There's also the option to adjust different rates of fuel consumption if a user wants to differentiate costs associated with fuel use according to different pavement conditions. When conducting this type of analysis, it's important to use a straight line growth rate. TREDIS has included a setting feature to select a straight line growth rate, which enables the estimated sum of both good and poor pavement to exactly match the original amount of VMT that's occurring in the study region. If a straight line growth rate is not applied, TREDIS uses a default compound annual growth rate, also known as CAGR, to fill in travel inputs for interim years. This may present a challenge if this compound growth rate is applied separately to different estimates of good and poor pavement, as shown in the top table. So to exaggerate these differences, if there's only 30% of good pavement was assumed by the year, in the year 2016, by the year 2045, with sufficient investment, that good pavement amount is expected to grow up to 80%. And the bottom table shows how the sum of good and poor pavement in interim years could differ from the original amount of vehicle miles traveled when a compounded annual growth rate is applied to good and poor pavement individually. Viewing this example in a graphical format can help illustrate the disparity. So adding in the good vehicle miles traveled, which is represented by the blue line, and then the poor by the red line, adding those together equals the green line of VMT. And note that the original amount that was estimated in the purple color line, we do see that there's a gap built for those interim years. And to address this disparity, a straight line growth rate can be applied if the other option that TREDIS provides is an import spreadsheet template, where each year can be specified individually. And that enables the user to indicate the exact value for each year to address any undesired trends associated with a compound annual growth rate. TREDIS also includes the ability to capture the remaining value that's associated with investments in transportation. All investments in transportation infrastructure have a certain number of years for which they're able to provide optimal performance. This period of years is what we refer to as the useful life. It can also be thought of as applying a rate of depreciation to the value of an investment. When evaluating a preservation program, annual investments during the latter part of the operational period use up only a small part of their useful life and are still considered to have value, as illustrated in this example. So if investments are made here in the years 2030, 2035, or 2040 towards the latter part of this operational period analysis, they will still have between 5, 10, or 15 years of useful life remaining. And that amount of useful life, the value associated is estimated using a straight line depreciated method. If other asset value methodologies are desired, the user can override these values and replace them with their own for what is estimated within TREDIS. Okay, now I'm going to go ahead and log in and give you a live demonstration of some of the unique aspects of this project example in terms of the inputs, and then we'll review some of the reports associated and some of the insights that can be gained. Okay. First, we're not going to go over each of the stages here. Kyle will touch on some of the ones that I don't cover, but I wanted to make sure that we highlight here on the modes stage something that's unique to this analysis. So in this stage, there are several different default modes and purposes that can be selected that are already available for the user. They're differentiated on the top by different purposes, such as business, personal, commute, or a combination of all together, which is labeled as no split. So in this example, we need to use the same mode purpose, but only differentiate the different modes by the operating cost associated with the pavement that the vehicle is riding on. To do this, we can create a custom mode down here at the bottom. And clicking on this will open up this window. And here we can label each mode according to the pavement condition, whether it's good or poor, and then which has been previously done. And so I've added one in here with the label good pavement and then poor pavement, as well as the same thing for within the truck purpose. And I've selected, for simplicity, the no split mode to combine all the different, the no split purposes to combine them all together. Once that's been done, then we go to the very bottom here and click on the cost and environmental factors. And you can see that I've already adjusted the vehicle operating cost to account for the 20% higher cost associated with driving on pavement that is in poor condition overall. So once that's all been completed there and those adjustments have been made, click on the Save button and you can continue on to the other stages. Quickly, I will go over the timing here. We have the period of construction from 2016 to the end of to 2045, which is the same time period as the operations. And this is just to allow us the ability to have a certain amount of investment on an annual basis. The region, as we already mentioned, is for Suffolk County, and we only have a base and a project alternative. So I'll jump over to the cost stage. Here, if we scroll to the bottom in the project scenario here, we're looking at investing in roughly $750,000 per year. The units used here are in millions of dollars, and this annual cost of investment reflects the work such as resurfacing and renovation focus. Next, we'll click on the travel characteristics tab, and I'll spend a little bit of time here reviewing the setup of the inputs. So here what we're looking at is for the year 2016. You can also select other interim years if interested, but we're going to just do a current year and a future year in year 2045. There's also a breadcrumb indicator here at the top, and it highlights in bold the years for which you have data entered in here. And you can see that there is roughly the same amount of information in terms of trips, miles, and hours associated with good and poor. And this reflects roughly that there is a 50% split between good and poor pavement, as we previously discussed. And this is the same for both the base case and the project case. So basically this is demonstrating existing conditions as they currently are. However, let's go to the future, into the year 2045, and we'll see there's a little bit of difference between the two. Now, in this year, we see that the amount of vehicle miles traveled for passenger cars traveling in poor conditions is roughly 94.5 million. And then in the project scenario, we see that due to the annual investments of roughly $750,000, that reduces the amount of travel in poor pavement down to $27 million, or 27 million vehicle miles. And then from the perspective of the good pavement, that starts out at roughly 40.5 million, and that increases all the way up to 108 million VMT. And similar improvements in pavement are also occur for the freight truck mode purpose. So those are the essential inputs that we're focusing on. And basically, this is a shift from what views like one mode to the other. What really it's doing is reflecting a change in the driving conditions, as due to the pavement preservation program, you're going from driving in poor conditions to good, and we're just shifting the amount of driving conditions from one mode to the other to accurately reflect how those conditions are changing. Okay, we'll click on the results tab here. Now we're first taken to a settings page, and this page has a variety of settings to select from, which changes the way the results are reported. And we have a couple of options that we can select from. And the first one that we'll go to here is the impacts type. Right now we're just focusing on the operational, or the impacts associated with the reduction in costs. The other options that are available are construction or other views, but to isolate just the impacts associated with vehicle operating costs from the amount of impacts associated with construction spending, we've just isolated on operational. Then here we have an interpolation method, a drop-down menu box, and because we just entered in the current and the future year for the base and the project scenarios, we have selected the straight line growth. The other option is to look at the compound annual growth rate. In addition, according to the, there's also an option to select the depreciation type, and because we want to include the value investments in pavement preservation, which still have remaining value after the year 2045, we've selected the annual program. If this was a project that just had a one-time investment of construction costs, which could span a couple of years, but typically are in the early years of the analysis, then the option would be a one-time project. Then there are other options here, other parameters that can be select that have default values, but can be adjusted to change according to your the settings features that you want to include. Then you can click on the Run Analysis tab, which we've already done for, so we can quickly review the reports. And the ones that I'll be going over are a couple of reports, including in the tracing and validation suite of analysis, benefit cost, and economic impact. First, we'll start with tracing and validation. And these suite of reports help to identify any data errors or intermediate calculations to trace the source of the results. If we click on the cost savings by type, it shows the changes in the vehicle operating costs for each mode purpose pavement condition. And the first column shows how much savings is occurring as travel on poor pavement is being reduced right here. And then the next column shows the additional costs associated with travel on good pavement as that amount increases. And the difference between the two reflects the net cost savings of now being able to travel on good pavement. You can also select a specific year, which will show you the specific savings, and we've identified that it's occurring here associated with the vehicle operating costs, which for the year 2023 is a little over $500,000. On the benefit cost overview, we see a summary of those cost savings associated with travel on improved pavement, as well as the costs associated with the program. If we click on the benefit cost overview tab, we see that over the years 2016 through 2045, the present value of over 22 million in operating costs is saved due to the program. The program costs about 15 million in present value terms. In addition, because of the investments made in the latter years of the program that still have remaining years of useful life, that amount of useful life is still valued at roughly about 3.3 million. Combining these two numbers together lowers our overall costs to have a present value of cost down to 11.8. And comparing these benefits and these costs results in a benefit cost ratio of roughly 1.9, indicating that for every dollar of investment in the program, you get $1.9 in total social benefit that is provided. I'll jump over to the economic impact tab. And this first, or suite of reports, and this first tab shows a linear graph of how economic impacts grow over the years 2016 through 2045. The next tab, total by industry. On the first row, it shows how what the cumulative impacts of the program are, and what they provide to the economy. So what's occurring is that businesses that save money due to these improved payment conditions use that money for other productive uses and can also lower the price of the products. Households also save money and then are able to spend these savings in other ways. And this combined response enables the additional sales, which lead to over 47 million in output, 30 million in value added, and 23 million in wages, and up to 19 jobs into the year 2045. So, and these impacts include additional spending associated with business-to-business purchases and also employees as they spend their wages. And now that we've clicked on one particular row, it shows the industry detail on which these industries are more responsive to these cost savings. So in the year 2045, we see that cost savings to businesses is driving growth for industries in leisure and hospitality, professional and business services, as well as financial activities. There's also household savings and respending, which is driving the growth in the retail sector as well. Now, these results only reflect the parameters of a payment preservation of roughly $750,000 per year, but could be scaled much higher depending on the size of the payment preservation program. And larger programs would likely have larger cost savings and therefore a higher magnitude of economic impacts. Okay, so we'll go back to the presentation here. So in summary, we see the efficiency effect of getting almost $2 of benefit for every dollar of cost. We see the magnitude of the contribution of additional wages and output and growth of jobs. And we're also able to see what businesses are particularly sensitive and respond well to cost savings and growth. And so these are the type of helpful insights that can be used in evaluating a payment preservation program and determining how does it benefit society, what particular aspects of the economy are improved, and what's the overall magnitude, which can provide helpful guidelines in making decisions regarding funding levels and duration. All right, now I'll go ahead and turn it over to Kyle.
Hi, thanks, Adam. So we're going to move on to talking about the next type of preservation program that you might want to use TREDIS to analyze. We believe that TREDIS is flexible to examine a wide variety of different bridge preservation programs, considering accelerated replacement or rehabilitation of bridges, or just better preservation programs and routine maintenance. We'll focus today on the transportation value of bridge programs, which is mostly looking at how weight posting or closing of facilities could lead to detours of passengers and freight, and how those effects have a cost to the economy and to society. There are several steps in the process of using TREDIS to assess preservation programs. First, we recommend you establish baseline volumes, VMT and VHT on the system. Then determine when diversions may occur under different funding levels tested by the asset management system. Also identify the characteristics of possible detours, especially the distance that vehicles would have to travel if a facility was not available. Add or remove these detour distances from the baseline to construct two cases for scenario analysis. There are many ways to set a baseline, such as keeping the network fixed in its present condition or state, using a baseline where full engineering needs are met, or setting a baseline that reflects planned or expected changes to the future network. Explicitly defining a baseline over the entire lifetime of the analysis is important for developing useful comparison cases. We recommend including total system travel in the baseline rather than only looking at travel impacts relative to a level of zero change, because establishing a complete baseline of all travel helps to assess relative impacts of your programs. TREDIS is designed for pairwise comparison between two cases. Each scenario has a base case and a project case, and you can test a variety of different programs against the level of funding associated with baseline travel characteristics, or compare other funding levels that would require addition and subtraction from the baseline. Your agency will also have to determine a consistent means for identifying potential years of posting or closures of facilities under different funding levels by using various asset management systems and tools at your disposal. Some agencies have used predicted superstructure condition ratings, which are associated with posters and closures at their lower levels, or agencies may develop other rules based on current management practices. The characteristics of detours might be included in agencies' management systems or from separate research in the state or the MPO region. The National Bridge Inventory is also a consistent source for this data and provides bridge traffic volumes and baseline truck percentages. The left portion of this table shows some of the inputs that may come from asset databases like the National Bridge Inventory, and that may be determined by analysis in asset management systems. The example we will be looking at in TREDIS today only includes these 10 facilities, which have synthetic volumes, truck percentages, detours, and dates of closure or posting. In the example, you can see VMT and VHT calculated in the final columns of the table for both trucks and cars based on the asset database information. The VMT and VHT from the previous slide need to be added together by year, since there are some years where multiple facilities close. This is transitioning from the analysis of individual assets to the preservation program's impact on the system. In the next table, diversions are added into baseline travel, which is increasing slightly from year to year due to traffic growth. In the portion showing truck diversions cause a bump in VMT and VHT in 2018. In TREDIS, we'll review how diversions phase in the later years. As you can see, in order to analyze some of a preservation program in TREDIS, there's some work involved in translating the outputs of an asset management system to the type of travel characteristics that TREDIS analyzes. However, there's a reasonably simple process that you can customize to the type of bridge management systems you're using and workflow in your agency. Accurate measurement of this type of program often requires year-by-year entry of data. TREDIS allows entry of multiple years and the ability to import projects using a spreadsheet that greatly simplifies adding a large number of years. My workflow on these projects is typically to go through the guided user interface to dimension a project, and then to create a project backup for uploading travel characteristics. We'll go back over to TREDIS now and see how that might be done. I'm going to return to the projects page in TREDIS using the same user as Adam was showing, and we have here the bridge project for today. You typically select the advanced project mode in the analysis type, and you can see that today we'll be looking at passenger cars and no split in in trip purpose and freight trucks collectively. Just as with Adam's project, we have construction and operations years that completely overlap, showing that we're spending money in each year of the analysis and also keeping track of travel characteristics throughout that time. In this case, we're looking at the entire state of Massachusetts in our economic model. Just as Adam used Suffolk County, this has already been built so that we can continue to look at the analysis and results. On the alternatives, you can see that I've renamed the project's scenario cases to be a little bit more descriptive and easy to keep track of. We'll be looking at a base case with a lower level of funding and a project case that meets full engineering needs and prevents any detours occurring. You could also use the alternatives here by adding an additional one to store other funding levels to do pairwise comparisons later. I've entered costs in both the base and project case, recognizing that there will be some money spent in both situations. However, in the full needs spending scenario, we're spending additional money on planning to replace bridges or do major rehabilitation. This, however, is leading to a decrease in the amount of money spent on routine maintenance from year to year. There's many ways to add additional analysis to your cost side based on how your program may impact future spending. We're focusing, however, on the travel characteristics, and you can see here base and project start with the same amount of travel representing a baseline. You can see all the years across the top are bolded in black, and this shows that all of them are active and contain data. To activate them, you go into the data year dropdown, and they'll initially be gray, just as you could see across the top in Adam's case. Now, when I'm planning to back up a project to make a simple import template, I simply select these years and then leave the travel characteristics in the table at 0. Once you've activated all the years that you want to use a spreadsheet to import travel characteristics, you can return to the projects page and enter group options. Select your program and create a project backup. The project backup sheet exactly matches the worksheet pattern expected during a project import. So you can export a project and make any edits to the data, including travel characteristics, as well as things like cost and access, and then import the project again. Once your project is imported, you can go to the results page to run it. We'll be selecting the base and project scenarios, but the results settings page gives you the option to select any two of your alternatives to do a pairwise comparison. In the economic impact reports, we'll be looking at total impact. Remember that Adam only showed operational impact, and there's other options to focus specifically on impacts from construction or from access measures. We've also selected an annual program in order to better capture the remaining value of the annual investments being made, rather than a new facility being created. You can see here by the blue button at the bottom that we've already ran analysis, but if you've just imported your project or have entered travel characteristics by copying and pasting values, this button will be yellow. When you run analysis, you'll land first on the summary graphics page. This tells a basic overview of your project, and you can see here that the total amount of money spent on our investment over 25 years is $112 million, and that this leads to decreases in vehicles mileage traveled in terms of avoided detours of 3.5% and time savings of 3%. These travel characteristic changes lead to societal benefits of around $10 million, mostly in terms of traveler benefits in time and vehicle operating costs. The economic impacts are around $8 million and split up in different sectors, as Adam reviewed as well. I'd like to go next to tracing and validation, where we can see everything from whether the data was entered as we expected to the calculations that lead to societal benefits and an economic impact. You can see here why it was necessary to enter multiple years of data, because we have bridge closures occurring in years that provide discontinuities from year to year. You can see we haven't entered any change in vehicle trips, and if we remove the vehicle miles travel measures from this measure, you can see a similar pattern in terms of vehicle hours saved. In some of the previous webinars and intros to TREDIS, we've reviewed additional information here, and I just want to quickly look again at the cost savings by type. In 2043, you can see how we're saving both time and vehicle operating costs for freight and passengers. There's also a safety benefit as we avoid additional vehicle miles of travel. In the benefit cost reports, you can see how the benefits of the project of the comparison between the two funding cases compared to the costs of a larger program. By clicking into a graph, you can see the components of benefits or costs. Here we see that overall, for freight and passengers, vehicle operating costs are the largest component of societal benefit. In the benefit cost overview, you can also see high-level measures such as net benefits and benefit cost ratios. I want to look quickly at the cost and net benefits table, and this is at a 3% discount rate. You can see here how we're having higher startup costs in terms of capital investment in the full engineering needs level of funding, but we've reduced operations and maintenance costs. And in the final year of analysis, we're providing a residual value estimate based on the remaining life of the bridges that have been rehabilitated or replaced. On the economic impact graphic, you can see that in 2016, you have some economic impacts which are entirely due to the money being put into the economy by the program. 2018 is the first occasion where we have vehicles beginning to detour. And as more detours occur, you can see the increasing impacts of the preservation program. You can look again at the impacts by industry and see how there's significant increase in construction value added and business output, which is a major component of the spending side of the investment plan, and also some of the major industries of the Massachusetts benefit by reduced miles traveled and vehicle operating costs. We'll return now to the presentation. And so just to review a little bit how we can see the value of a maintenance program or a more major capital preservation program in TREDIS by looking at measures of social benefit and economic impact. TREDIS provides a variety of measures at different levels that can be used to assess the efficiency of preservation programs. You can see in this project that we have a benefit cost ratio greater than 1 and $7 million in net present value. The importance of both construction activity and savings in terms of time and money can be seen in the economic impact reports. And in this case, in the year 2040, they're almost equal at $42 million from each area. These measures may complement other justifications for preservation programs as well. Additional levels of detail can be added to preservation programs and analysis, such as pavement and bridge. In the case of a bridge program, you may want to look at scenarios where postings and closures are expected to occur in both analysis cases. You could also add additional network modeling in addition to information from the asset management system and asset databases due to interactions between closures of bridges on the same highway or street networks. Different facilities could have specific travel growth rates to look at different areas of the state, and you could, as Adam mentioned, improve the calculation of the remaining value by doing calculations based on backlog values or other estimates of how much money would have to be spent to reach the same level of service sometime after analysis. Let the moderator take the program back from us.
Thank you, Kyle and Adam. Thank you for your presentations. We'll answer the audience's questions in just a moment. If you haven't yet, you can enter your question into the webinar chat box now. Just wanted to point out that if you actually haven't been to one of the Introduction to TREDIS webinars, the recordings of our previous events are posted in the webcast section of the TREDIS website, and the link is up top here on this slide. We'll be posting a recording and the slides of today's event in the next day, and if you'd like to share that information with your colleagues, please feel free to do so. We're happy to have you join that. Okay, now for your questions. Yeah, I just answered the question that the first questions we have is, will the slides be available? Yes, they'll be on the webinar recording page. We'll have a link for that. We have a question here. Considering the types of programs we're talking about, your project numbers seem small. Is TREDIS scalable, and can it handle statewide programs?
I guess I can answer that since the example that I used was fairly small. Yes, of course, it is scalable, meaning you could have input values that are much larger in magnitude to the ones that I use. So if there is, roughly, I used, $750,000. It could be a program where you're spending up to 200 or 300 million per year for a large metropolitan area, and then the amount of pavement improvement could drive a significant amount of vehicle operating cost savings, which then would translate into an economic response where businesses are able to generate additional sales, employ additional workers, and additional successive ways of spending, as well as households will be able to redirect their spending from their deteriorated cars from all the potholes that are in the ground to other discretionary categories. So yeah, so you could take this example and increase it by a factor of 10 or a factor of 100. It definitely is scalable to the size of the program that you're evaluating.
Thank you, Adam. Another question. Are default travel costs available in the model for the region selected? Default travel costs.
The TREDIS default mode purposes have vehicle operating costs, fuel consumption rates that are associated with national averages, but you have the ability to make any of the default modes, modify any of them to have more regionally specific costs if you have information on your specific MPO region or state, and custom modes as well allow you to create copies off of any of those, including any modifications that you've made, and then adjust them if you want to do something like a pavement preservation program that has two different cost levels for vehicle operating costs.
And let me also add that they are updated periodically, so they do stay current. So so that's something that is monitored on a regular basis to make sure that the values remain current.
And we do post technical advisories when any updates are made to the model. So that's available in the user resources library when you've logged into TREDIS. Next question. I haven't used custom modes yet. Is there anything I need to be mindful of when creating custom modes? Will the modes I create be available to me on future projects?
Yeah, that's one of the features that we wanted to highlight in this example, is how custom modes can be used to enable an evaluation of, in this case, an asset management program focusing on pavement preservation. So this capability enables this level of analysis, and the only thing I think that would be necessary is just to make sure that you have a proper label and that you have accurately modified the characteristics that differentiate the two different modes. We do have the capability also of having a custom mode made available to other users that are also have logins that are under your same contract, because we do know that there are organizations that do have specific types of analyses where they want to customize specific characteristics or values of a particular mode purpose and then share that across the organization. So the only thing that I would say is number one, awareness. Number two, making sure you modify those modes. And then three, those can be shared across the organization.
And probably good to note that you should be communicating within your organization what maybe those modified custom modes mean within your organization. So pointing that out. We have one more question here. If you haven't answered if we haven't answered a question that you might have, please feel free to enter it. If I receive a benefit cost ratio lower than 1, does that mean I shouldn't invest in a project?
Yeah, well, I think in the example today for bridge preservation, we saw a relatively lower benefit cost ratio, not a huge number of net benefits. But I think it's totally reasonable from a lot of agencies that we've spoken with to see those kind of results in a preservation program. You're often going to get much higher numbers, bang for your buck from big capacity programs, but there's a lot of other considerations that agencies are including in their analysis now to try to make sure that they steward the resources that they have. So we really think that TREDIS has a lot to offer in terms of understanding the resource efficiency from a benefit cost analysis, the economic impact, but it's probably part of a suite of measures and metrics and information that the agency might have to really understand how their program works. And also important to, when you see those kind of results, make sure that you're including all of the expected benefits and impacts in the project in terms of inputs and the cost side and the travel side, and also that it's simply not possible for some frameworks like benefit cost to include all of the really important factors when considering how to move forward with a major preservation program.
We do have one more question. Could you explain why jobs are created within a preservation program? We saw some jobs were created.
Yeah, so that's a good question, and that's one of the critical insights that we are getting from this analysis, is that the theory behind it is that when you have cost savings, which are focused on cost savings regarding with vehicle operating costs here, those cost savings then trickle down to the users or associated with the users. Now we've identified that majority of the traffic here is passenger car as well as truck. So who are those users? Well, you've got households. We did use a no split mode purpose, but that's kind of a combination of all the different purposes. So you do have some commuters or people that are on the clock, as well as freight that's being shipped and received. So what's happening is that those cost savings are accumulating to businesses, and that could be people commuting to work, or like service and repair individuals, or it could also be people that are shipping goods that they've manufactured or that they're receiving that are part of their manufacturing process or part of retail. So anytime you save money due to less wear and tear on your vehicle, that money then accumulates within an organization or within households, and so they can then determine how do they use that. A lot of times businesses that we've seen from studies will do a number of things, but primarily they often have the flexibility of lowering the cost of their product. So, and that also then generates additional demand. If anytime there's a price reduction, typically there's an increase in purchase of that good or that service. And so they can expand that economic activity, which creates jobs, creates wages, creates sales. And then also households are able to use that money that they're saving and no longer spending on very costly repair to replace their shocks or their struts or whatnot, and they can use that for other means. And so that money is redirected to other parts of the economy. So that's how kind of we view the cost savings as generating additional economic activity, because there's additional purchases being made. Included in that analysis, we know that there's a lot of industry and supply chain business-to-business relationships that are going on, and so anytime a company is able to expand their sales, that means they have to purchase additional inputs, which could be goods or services. And so there's successive waves of spending. In addition, also newly hired employees will spend their money in the economy. So all of that amount of additional economic circulation that's occurring that doesn't that's staying within the region, we are evaluating that and summing that up, and that gives a perspective of how much the economy is growing and then also which industries are benefiting the most.
Thank you. So that seems to wrap up your questions. If nobody else has anything today, we'll take this moment to say thank you for your time. And if you want more information about purchasing or using TREDIS, you may call or email us. And if you have any questions or have feedback about this webinar, please feel free to contact us. We hope to see you next time. Thank you.